Our today's subject of discussion is maximum speed test, applicable to motorcycles, scooters, auto rickshaws, or any other power-driven vehicle. It would be appropriate to keep in mind the prerequisites, preparations, and protocols for the standard testing procedure for complete motorcycles, as we had discussed before. To perform the maximum speed test, please ensure that the test track includes a sufficient pre-run acceleration zone before the designated test section and an adequate braking zone after the test section. This allows the vehicle to safely reach and maintain its maximum speed for the test throughout the measurement zone and to come to a complete stop after the test. As you can see from this illustration of the test track, this is the starting point or the origin. The motor vehicles enters at this point. From this point to the X1, this is sufficient time. There is a sufficient distance has been provided to accelerate the motor vehicle. From the point X1 to the point X2, the total distance is S meter, and this is constant maximum speed zone where the motorcycle or motor vehicle travels at its maximum speed from X1 to the point X2. From the point X2, the brakes are applied gradually, and this zone is called braking distance or braking zone. And after this braking zone, at this point, the motorcycles or the motor vehicles exit from the test track. The key point is, as soon as the rider enters the test course, he is required to accelerate the motorcycles through the pre-run distance to achieve maximum speed as far as possible before entering the measurement zone of the test course. He will maintain this speed steadily as he passes through the measurement zone of the test section. The time taken to pass through this measurement zone, that is from the point x1 to x2, as shown in the illustration, will be recorded. After recording the time, the maximum speed will be calculated by using the following formula. Maximum speed V is equal to S divided by T multiplied by 3.6, whereas S is the distance from the point x1 to x2 in meters. T is the time required to travel from the point x1 to x2 in seconds. To calculate the maximum speed, we use the formula maximum speed is equal to S upon T, where V is maximum speed in meters per second, S is measured distance in meters, T is time consumed in seconds. Now we are required to convert meter per second to kilometers per hour. We know 1 kilometer is equal to 1000 meters. 1 hour is equal to 3600 seconds. Therefore, our conversion factors are 1 meter is equal to 1 by 1000 kilometers, and 1 second is 1 upon 3600 hours. To convert 1 meter per second, we multiplied by 1 divided by 1000. That is to convert from meters to kilometers. To convert second to hours, we divide 1 by 3600 because second is a denominator, so the multiplication factor will be 3600 divided by 1h. By cancelling meter to meter, seconds to second, we get 1 meter per second is equal to 3600 divided by 1000 kilometer per hour. That is equal to 3.6 kilometer per hour. Therefore, final conversion factor is equal to 1 meter per second is equal to 3.6 kilometers per hour. Let's go through an example to compute maximum speed. As we have previously said, maximum speed is equal to B is equal to S upon T in meter per second, or B is equal to S upon T multiplied by 3.6 kilometers per hour, where V is maximum speed in kilometers per hour, S is measured distance in meters, T is time consumed in seconds. The factor 3.6 is used to convert from meter per second to kilometers per hour. Now in this example, suppose a motorcycle or scooter or any other power-driven bike travels 200-meter distance in 8 seconds. Then the maximum speed will be V is equal to 200 divided by T into 3.6. That is 25 into 3.6. That is 90 kilometers per hour. With this, we conclude our today's discussion on the subject of maximum speed test. Please do drop your comments, share your experience, and don't forget to like, subscribe, and share. Our next topic of discussion will be acceleration test. Thank you, and thank you very much.